We are going to look at the Thanksgiving balance forces practice. Number 1, an engine with a mass of 500 kilograms is pulling a coal car that weighs 2,000 newtons. The engine pulls the coal car with 800 newtons of force, and then the pair moves at a constant speed covering 10 meters in each second. So because it is a constant speed, that means that on our velocity timetable, that is going to be constantly at 10 meters per second. So now I've labeled the seconds on the velocity time graph. I'm going to do this by 5 and 10, -5 and -10, and we're going to graph the velocity time graph. The velocity is at 10 meters per second in the positive direction, so it's going to be graphed at 10 meters per second. It's just a straight line straight across. Now, to get the position, we're going to assume that it is at 0 when it first starts, so 0 meters. Okay, so I don't have to keep writing S. I'm just going to title my table with the S for seconds. Okay, and it's going at a velocity of 10 meters per second. So when I calculate the area, I have 1 times 10, it's going to be plus 10, so 10. And since it's constant, I know that I could just add 10 to whatever this value is and still get the right answer. So all right, and now for my graph, I'm going to do this by tens on the side. Okay. My position in meters and my time in seconds. I start at 0, 0, then I go to 110, 220, 330, 440, 550, and 660. And I know to just go ahead and make a straight line. That's the position time graph. Now for the interaction diagram, the coal car, and so here's Earth, E for Earth, C for coal car. Since I'm already using E for Earth, I'm going to just say T for engine car. And then for the railroad tracks, I'll say R for railroad. Okay. The interaction between the engine car and the railroad, so T and R. The interaction between the coal car and the train. And then everything to the earth, so CE, TE. Okay. The coal car is, because it is constant, it is a balanced force. So the coal car is being pulled down by force of gravity on the coal car by the earth. And from our information here, the coal car that weighs 2,000 newtons, so the weight is also the force of gravity, which is 2,000 newtons. It is also being pushed up by the railroad track. The railroad track is pushing on the coal car at the same force that it is being pulled down by the earth. The coal car is being pulled in this direction by the engine car. So I'm going to write pulled the coal car by the engine car at, from our information here, the engine pulls the coal car with 800 newtons of force. So here I'm going to write 800 newtons of force. And we know that it is a balanced force, so then the force of friction on the coal car by the railroad track is going to also be 800 newtons. And then for the engine car, it is a balanced force because it is going at a constant speed and is being pulled down by the force of gravity on the engine car by the earth. It is being pushed up. The engine car is being pushed up by the railroad tracks. Because the engine car is pulling the coal car this way, the coal car is pulling the engine car the other way. So for our picture, the coal car is pulling the engine car in this direction. And we also know that since it's balanced, there must be a friction force on the other side to keep the numbers balanced. So now we know that the engine car weighs 5,000 newtons. And so it is being pushed up at also 5,000 newtons. This is going to be 800 newtons because that's how much it is pulling the coal car. And then that means friction is also working at 800 newtons. Our friction pair, or our Newton's third law pair, our Newton's third law pair has the same force type and the same feelers and dealers. Okay, so here, write the N3L pair between the engine and the coal car. So it is going to be the pulling motion on the coal car by the engine car in this direction is paired with the force of tension on the train car by the coal car in this direction, and it's happening at 800 newtons. Okay, and what is the force of friction acting on the engine? The force of friction acting on the engine is the force of friction on the engine car by the railroad track. So railroad track in the right direction at 800 newtons. And then this other question is, how far does the engine move in 3 seconds? Well, we'll just see here. The engine moves 30 meters in 3 seconds. And that we get that from the distance is equal to rate times time. The rate is the velocity, which is 10 meters, and 3 seconds, which is 30.